Hi everyone, I'm Ming Tsang, and today I'm happy to give a video abstract of my recent article comparing Hecke eigenvalues for pairs of automorphic representations for GL2, which will soon be appeared in Journal of Number Theory. So let's start with notations. So let's F be number field, AF be the Adele ring of F, and pi1 and pi2 are unitary cuspidal automorphic representations for GL2, and let T be the set of all Archimedean places, as well as some finite places of F at which pi1 or pi2 is ramified. In fact, we can associate incomplete L functions to pi I, which is given by the products of all places V, which is not in T of this local L factor. And this local L factor is in fact the determinant of the identity matrix minus the AV pi I, which is the length conjugacy class of pi I at V times the norm of V to the power negative S, and the whole thing to the power negative 1. And we also denote the small letter AV pi I to be the trace of the length conjugacy class of pi I at V. Okay, so now let's get into the question of interest. We're interested in asking, under what conditions are pi1 and pi2 equivalent or the Swiss equivalent? So let us consider the set S, which this set is the set of all places V, which the AV pi1 is not equal to AV pi2. And the strong multiplicity 1 theorem for GLN, which is the work by Hecke, Piatowski, Shapiro, and Shalika, says that, oh, if this set is finite, then we can say that pi1 and pi2 are equivalent. Now we can say more about it. We have some refinements, which is for GL2, and Ramakrishnan in 1994 showed that if pi1 and pi2 are distinct, then the lower Dirichlet density of this set S has to be greater than or equal to 1/8. And the bound is sharp. Now, why I'm saying that this is the improvement or this refinement of the previous results, we consider contra positive of this statement. If the lower Dirichlet density is strictly less than 1/8, then we can say that the two representations, pi1 and pi2, are equivalent. So notice that if S is finite, the set S is finite, then we'll have the density to be 0. Okay, so let's move on to the next refinement, which is by Walji in 2014, which says that, oh, if pi1 and pi2 are not Swiss equivalent, then the delta S is greater than or equal to 2/9, and this bound is also sharp. Okay, let us consider more interesting variants of this question. So we let this S star to be the set of V, which is the set of places, which AV pi1, the modulus of it is not equal to the modulus of AV pi2. And we also consider the set S star with a superscript strictly greater sign, which to denote the set of all places V, which the modulus of AV pi1 is strictly greater than the modulus of AV pi2. And it's not hard to see that the S star pi1 pi2 is equal to the set S star with the strictly greater sign pi1 pi2 union with the S star with the greater sign pi2 pi1. Why this is true? Because like if they are not equal, then either the first one greater than the second one, or the second one greater than the first one, right? Okay, and we have the following known results, which is by Wang in 2022. So if pi1 and pi2 are not Swiss equivalent, then we know that the lower Dirichlet density of this set S star should be greater than or equal to 1/10.76. And if we further assume that pi1 and pi2 are non-solvable polyhedral, then the bound is improved to 1/9.9. Okay, here is the main theorem of this article. So suppose pi1 and pi2 are not twist equivalent, then we can say that the lower Dirichlet density of the set S star with a strictly greater sign is greater than or equal to 1 over 16. And this bound is sharp. Moreover, if we assume that both pi1 and pi2 are non-solvable polyhedral, then the bound is improved to 1 over 13.93. Now, you might ask, so how does this result compare to the previous one? In fact, here comes the corollary. And the corollary is basically the use of the fact that this S star is equals the union of S star greater sign pi1, pi2, and pi2, pi1. So the corollary basically says that if both pi1 and pi2 are not twist equivalent, then we notice that the lower Dirichlet density of this S star is greater than or equal to 1x. How we get that 1x is just basically 1 over 16 plus 1 over 16. Moreover, if we further assume that both pi1 and pi2 are non-solvable polyhedral, then we get this lower Dirichlet density to be 1 over 6.97. Again, how we get this 6.97 is just 1 over 13.93 plus 1 over 13.93. And you can see the bound 1 over 8 and 1 over 6.97 is better than the bound like 1 over 10.76 and 1 over 9.9 here. So, and this basically is the main theorem for this article. Thank you for listening.